For this question, we want to find the rule that describes the piecewise defined function. So we have a picture which is representing a piecewise defined function, and we want to find the rule or the equation that matches this picture. So looking at this, I have two pieces of the picture. I have this linear piece, which is going to be a straight line, and then I also have this curved piece, which looks like a parabola. So I'm going to have a function, a piecewise defined function that has two equations, and then along with those equations we'll have some conditions. So let's start with the conditions. So on the linear piece, I can see that my that piece starts at -7, and that piece stops at -2. So for the linear piece, I am going to have the condition that x needs to be in between -7 and -2. And as I look at this endpoint here, that's a filled in dot. So I'm going to put an equal to on the -7. However, there is an open circle on this end, so I don't want to include the -2. Let me make a correction here. I forgot to put the inequality symbol. So for this one, I will not put the equal to under that inequality symbol so that that endpoint of the line is not included. Then for the other piece of the line, which is the parabola piece, you can see that that piece starts at -2 and then stops when I get to 3. So for this one, x will be in between -2 and 3. Looking at one end, we have the open circle, and on the other end, we have the closed circle. So on the closed circle, I want to put the equal to, and on the open circle, I don't put the equal to. Then we want to find the equation. And by the looks of this equation, it looks like my basic graph of a parabola, which is the x² function. You can see that it's got its vertex at the origin, so it hasn't even been shifted left or right or anything. So the parabola equation is x², the basic function of x². And then for the linear function, we have 2 points on the line, and we can find the slope and then the equation of the line. So the 2 points on the line for this one are -7, -6, and -2, 4. I'll let one point be x1, y1, the other one x2, y2. I can calculate the slope using the formula y2 minus y1 over x2 minus x1. So substituting into that formula, I have 4 minus -6 over -2 minus -7. If I simplify, that's 4 plus 6 over -2 plus 7. That's 10 over 5, which is 2. So I have a slope of 2. And I'll choose one of these points. I usually like to choose the point with the smaller numbers. And I'll use point slope form to find the equation of the line. So that's y minus y1 equals m times x minus x1. So y minus 4 equals 2 times x minus negative 2. So y minus 4 equals 2 times x plus 2. Then I'll distribute the slope of 2 to give me 2x plus 4. I'll add 4 to both sides, giving me the equation y equals 2x plus 8. So now we found the equation of the line to be y equals 2x plus 8. So we'll use 2x plus 8. So we found our rule or equation for the piecewise function, and that is that it's 2x plus 8 for x's that are from negative 7 to negative 2, and x squared when x is from negative 2 to 3. For this question, we have the graph. We want to use the graph of a basic function and a combination of transformations to sketch the function. So our function is g of x equals negative x plus 2 squared minus 4. So we want to figure out what the basic function is first, and we have a clue right here. Our clue is this squared. So our basic function is y equals x squared. And we know the graph of that is a parabola where the vertex is at 0, 0. And then we have a bunch of transformations that are occurring for this function. And these transformations are the negative, the plus 2, and the minus 4. Those are all the operations that you don't see in our base function x squared. So we have the negative, the plus 2, and the minus 4. And each one of these transformations will do something different to adjust the graph of the basic function. So I have a little flow chart over here. We're going to take a look at these different transformations. So we have a transformation of a shift, and a shift is when you are adding or subtracting. So if your operation is adding or subtracting onto your basic function, then you may have a shift in the graph. That adding or subtracting can be inside or outside the base function, and that makes a difference about whether your shift is going to go up or down, or left or right. So if our adding or subtracting is on the outside, we're either up or down. If you have a plus, it's up. If it's a minus, down. If your adding or subtracting is on the inside of your base, plus is to the left, minus is to the right. So that's one type of transformation. Another type of transformation is when our operation is multiplying by a negative 1. And that transformation is called a reflection. So if you multiply by a negative 1 on the outside, you have a vertical reflection. Everything above the x-axis gets mirrored below. If your negative is multiplied on the inside of your base function, you have a horizontal reflection, and everything that's on the left is mirrored to the right, and everything on the right is mirrored to the left. And then we have a third type of transformation, and the third type of transformation is called a stretch or compression. And a stretch or compression happens when you multiply by a number, You can multiply on the outside or multiply on the inside. If you multiply on the outside, you have a vertical, either stretch or compression. It's called a stretch when the number is bigger than 1. It's called a compression when it's in between 0 and 1. If your number is multiplied on the inside, you have a horizontal stretch or compression. If the number is greater than 1, it's a compression. If it's in between 0 and 1, it's a stretch. So this is the information that we're going to use to decide what type of transformations are occurring for our example. So in our example, we have this negative being multiplied, which means that it is a reflection. And because that negative is on the outside of our base function, it is a vertical reflection. The +2, plus is adding or subtracting, meaning that this is a shift. The +2 is on the inside of the base, making it a horizontal shift. And because it's plus, we're going to shift to the left 2 units. The -4 is also adding or subtracting, making it a shift. And because that -4 is on the outside of our base function, it's a vertical shift. And because it's minus, it's down 4. So this information is going to help me draw the graph. I'm going to make these transformations on the basic function. So we're going to start with the basic function and do these transformations. It's important to know what order to do them in because you may get a different graph based on what order you do. And for the order we're going to follow is we're going to do our horizontal transformation first, then we'll do our reflection, and then we'll do our shift. It's basically following order of operations. We do what's inside the parenthesis, then we do multiplication, and then we do the subtraction. So our basic function starts off looking like this here. It's a parabola with a vertex at 0, 0. Then we're going to shift all of these points to the left 2. So all of the points move to the left 2, and then our whole parabola is shifted left 2. Let me change colors so that you guys can see the difference on each one of these. So shifting left 2 would give us a parabola like this. Then the next transformation is reflecting. Everything that's above the x-axis gets reflected below, mirrored below, and then finally we will shift down 4, moving our vertex down 4. And this is going to give me my final graph because it's the final transformation. So the graph in red represents all 3 transformations. That's f of x equals negative x plus 2 squared minus 4, and will be our final graph. For this example, we have a question that says use the graph of the known basic function and a combination of horizontal and vertical shifts to sketch the function. Our function in this example is g of x equals absolute value of x minus 4 minus 3. So I need to figure out the basic function first, And these absolute value symbols give me a clue as to what the base function is. So our basic function is y equals absolute value of x, and the absolute value graph is the graph that looks like a V, and that V is at the origin 0, 0. And then we can see some differences between the basic function and our function g of x. These are the transformations. We have a -4 and a -3. So our transformations consist of -4 and -3. Both of them are adding and subtracting, so we know that they are both shifts. The -4 is on the inside of the absolute value, making it a horizontal shift, whereas the -3 is on the outside of the absolute value, so that's a vertical shift. A horizontal shift is left and right. This being a minus means that we're going to shift to the right 4. Vertical shifts are up and down, and this is a minus, so it will be down. So our basic graph of absolute value of x will be sketched out like this. And then I want to do the transformations. I'm going to do the transformations in the order, doing the horizontal transformation first and then the vertical. So we want to shift right 4. If I shift right 4, that would get me to this graph here. Trying to use a different color so you can see it. That's the absolute value graph shifted right 4, and then we'll shift those points down 3. And I'm going to draw this solid because this is the final graph. This is the graph of g of x equal absolute value of x minus 4 minus 3. Use the graph of the known basic function and a combination of horizontal shifts, reflections, and vertical shifts to sketch the function. The function we'd like to graph with transformations is g of x equals negative x cubed plus 3. First, we're going to recognize what our base function is, or basic function. And that is going to be y equals x cubed. So I know it's y equals x cubed because of the cube here. So I need to know what that basic graph looks like. I know it passes through 0, 0. And at 0, 0, it has sort of a little squiggle in the graph. But mostly we see the left end quickly going to negative infinity and the right end going to positive infinity. Then we want to look for the transformations in this particular equation. In this equation, we see this negative that's out front, that's one transformation, and then we have this plus 3 that's added, and that's another transformation. Now, with my transformations, I need to have them memorized, and whenever I have a negative multiplied, I'm going to have a reflection. When the negative is multiplied on the outside, like this one, it's a vertical reflection. So that's a reflection over the x-axis. Whenever I have adding or subtracting, that's when I have a shift. This plus 3 is happening outside of the base function, so I know it's vertical. When it's outside, it's vertical. And vertical is either up or down. Because this is a plus, it is up 3. So what I am going to pay attention to is, remember that the base graph crosses through 0, 0. So a reflection is not going to affect that 0, 0, but a shift up will affect that 0, 0. So I'm going to shift that point up 3. And then the reflection will change this portion that goes up. It will make it reflect down. And this portion that is down, the reflection will make it go up. So that gives us a sketch of our graph of g of x equals negative x cubed plus 3. So that gave us our basic graph reflected vertically and shifted up 3. For this question, we want to use the graph of the known basic function and a combination of horizontal and vertical shifts to sketch the function. Our function is h of x equals the square root of x plus 1 plus 4. I'm going to write that a little larger. The square root of x plus 1 plus 4. So first we want to figure out what that basic function is, and there's a clue in our equation. We have the square root, and that means that our basic function is y equals the square root of x. The graph of that basic function is half of a sideways parabola, the top half of a sideways parabola. I can also see that we have some transformations within our function. We have a plus 1 and a plus 4. And we want to think about what those transformations are. The plus 1 and plus 4 are both transformations. Because they're adding and subtracting, I know that those are shifts. The plus 1 is inside the radical, so that is a horizontal shift. And the plus 4 is outside of the radical, so that's a vertical shift. Now, horizontal could be either left or right. Because this is a plus 1, I know it's going to move to the left 1. A vertical shift is either up or down, and because this is a plus 4, I'm going to go up 4 with my graph. So now I'm ready to graph my function using these transformations. I would start off with my basic graph. My basic graph is that half of a sideways parabola. And then I'm going to do the horizontal shift first and then the vertical shift. So my horizontal shift will move to the left 1 unit. And then my vertical shift will move up 4 units. I should have used a different color there. So okay, good, I did. So this is the graph. The purple graph is the graph of our basic function shifted to the left 1 unit and up 4 units. Thank you for checking out my videos. Have a great day.